This is higher homework. It's practice paper C and we're looking at question 21 and it's in the non-calculator paper. Right, so what we've got is we've got a function that's defined by f of x is equal to 2x cubed minus 3x squared, where x is a real number. Right, so the first thing what we've got to do with the function is find the coordinates of the points where the curve with the equation crosses the x and the y axes. Okay, so let's go ahead and do that. Right, so for part A, what I'm going to do is to find out where the curve crosses the y-axis. So for the y-intercept, what I'm going to do is I'm going to let x equal to 0. Because anywhere on this y-axis here, the x-coordinate is going to be 0. So I know that anywhere at all on that, x is equal to 0. So if I let x equal 0, I'll find out what y is equal to. Right, so from there, what I'll do is I'll start off with f of x is equal to the equation. Right, I've said I'm going to let x equal 0. So I'm going to just change that to y. So I've got a y coordinate here. So that's 2 times 0 cubed minus 3 times 0 squared. So what that's going to give me is, that's going to give me a value of 0. So the first coordinate that I've got there is x is equal to 0, which I said it was going to be at the start. And for that, y worked out to be 0 there as well. Okay, so that's the first coordinate that I've got. What I'll do now is I'll find out where it crosses the x-axis. So what I'll say for the x-intercept, or intercepts, what I'll do is I'll let y equal 0, because anywhere on the x-axis the y coordinate is going to be 0, there's no height to it at all, okay, so y is going to be equal to 0. So what I'll do is from this side here, I'm going to start with a 0 on the left hand side, and what I'm then going to try and do is I'm going to work out the values of x from there. So when I see something like this, okay, what I'm going to do is I'm going to take out a common factor to try and factorise this. So a common factor that I have here, I can see that I've got x squared will be taken out as a common factor. Right, so x squared out, and I've got a single bracket, so that will leave me with 2x in there minus 3. And I'll just check that if I multiply that back out, I come back to the original, which I do there. From here I can say that x squared equals 0, so x equals 0 there. So that's the same point up above, but I've still worked that out in a different way to find out the x-intercept. And from here, what I can say is 2x minus 3 equals 0, so 2x equals 3, or x equals 3 upon 2. Okay, so it's a fraction. So here I've got 3 upon 2, 0. Because remember I said I would start with y equals 0, so 3 upon 2, 0. So that's a couple of coordinates that I've got already. So there's the coordinates that I'm starting with. So, and that would be part A complete. Right, so let's go ahead and we'll start with part B. Right, so for part B, what we have to do is find the stationary points on the curve and determine their nature. Right, here we go. So what we'll do is we'll start off with the curve. And remember what we'll do here is it's a differentiation that we'll go from there. So that would be 6x squared minus 6x. For stationary points, so remember for stationary points, what I'll do is I'll let f dashed x equal to 0. Because remember that's just the gradient. So the gradient I'm going to make equal to 0. So I've got 0 at this side here. And what I'll do is I'll factorise this out just now by taking 6x outside the bracket, and I've got x minus 1 that would be left inside there. From there I can see that for my stationary points I've got 6x equals 0, so I've got x equals 0 from that side. I'll just write it up with the 6x in. And from this side here I've got x minus 1 equals 0, so x equals 1. So they're my stationary points there, or my x coordinates so far. What I can then do is work out my y coordinates. So the y coordinate, when I've got the x coordinate equal to 0 in there, okay, so I'll just substitute it back into the main equation, okay, and I've done that already, but I'll just show how that works out. So that gives me a 0. So I've got a stationary point of 0, and the x and also the y intercepts is going to be equal to 0. So if I then take this x is equal to 1, so if I substitute a 1 into the equation, and remember it's the y equals, or the fx equals, so I've got a 1 in there cubed. I'm going to take away 3 times 1 squared, and what I have here is 2 times 1 cubed is just going to leave me 2, and that's going to be minus 3, so that's going to give me an answer of minus 1. So remember I started off with x equal to 1, so I've got 1 and I've got a minus 1 there, so that's the coordinates there of my stationary points. Right, so let's see what we're going to do next. So what we'll do once we've got the stationary points, I need to know the nature of them. So let's do a nature table, and what we'll do is we'll work through a nature table on this here. So I'll have some x coordinates there, and what I'll have is I'll have f dash x, or dy by dx if that's what we're trying to work out, and the part of the equation that I can use anything that's the f dash x equation. So I could use this one, I'm going to use this one here. So that's going to be 6x times x minus 1. And remember, all I need to know is if it's going to be negative or positive, and that will tell me the shape of the graph. So what I've got here is, when I worked out my x coordinates, I've got an x coordinate of 0 and I've got an x coordinate of 1, and they were my my stationary points. So I know that the gradient, or f dash x, is 0 at these points here. Now all I need to do is think about a point that's coming towards 0, between 0 and 1, and then going away, so that I can get to know the shape of the curve. So just approaching 0 would be minus 1. How about going for a half that's in between 0 and 1, and from here let's go for 2 that's just beyond the 1. Right, so if I substitute a minus 1 into this equation here, what I'll get out is I'll get 12 out. So minus 1 going in there, that'll be minus 6. Minus 6 times minus 2 gives me a positive 12. So that's going to be a positive number there, positive 12. If I substitute a 2 in to here, that's going to be 12 times 1, so that gives me 12 at this side here as well. If I substitute a half in, what I'll get out is I'll get a negative, and it'll be negative 3 upon 2, if I just work that one through there as well. So what I can then say is that I've got the shape of the graph is going to be positive from here, it's going to be flat where it's 0, negative because that's a negative value there, flat, and then it's going to come up there and go positive. So there I've got a maximum, and there I've got a minimum. Maximum where it turns at the top, minimum where it turns at the bottom. So what I can state here is that the curve is a maximum turning point at, and let's see, the coordinates would be maximum is 0, and 0 matched up with 0 when we worked that one out, so 0, 0. And the curve really has, I guess it should be, a minimum turning point at, and remember the x coordinate was 1, and that gave me minus 1, so that'd be 1 and minus 1. Okay, so that would be part B complete to there. Right, so I've now to sketch the curve from part C, part 1. Right, so I know that that's the shape of my curve, so that's the kind of curve that I'm going to try and draw on the axes that I have here. So what I'll do is I'll kind of label the points that I've got so far. So there was one of the points I've got there. One of the points I've got is 1 minus 1. So if I just imagine going along 1 and I'll go down 1. So how about going to there? So that there will be 1 minus 1. And that's where one of my turning points are. And the other x-axis intercept was 3 upon 2, 0. So that's like 1.5, 0. So 1.5, 0, how about going to there? So that would be 3 upon 2 there. 0, 0 there, 3 upon 2 there, and remember that's the shape of the curve there. So it comes up here to my first stationary point, it will turn there, come back down, turns here, and goes back up through the axis there, and like that there. So that's the curve complete, drawn. So for C part 2, what I've got to solve is 2x cubed is greater than 3x squared. So let's start with that inequality there. What I'll do from there is I'll get things to be equal to 0, so I'll bring the 3x squared to the left hand side, so that would be minus 3x squared, and that's greater than 0. Now that there is the exact same as what the function is, the function that I've drawn, so what I'm really interested in, whereabouts is the function greater than 0. So if I look back to the graph, I can see on the graph that where it's greater than 0 is here. So it'll be all the values that go in that direction from that point that's there. So what I can simply say is that x is going to be greater than, and it's the point that's here, which is 3 upon 2. And that would be that complete. Right, let's have a look at where we're going to get the marks for this question here. So let's go for the first mark. We'll be for getting the 0, 0 that's there. That's the first intercept. The next one I'll get for factorising this part out here and making it equal to 0, and for getting the other coordinates of the intercepts that's there. So that would be the x-intercepts. So that's the 3 marks for part A. For part B, let's go for the first one, differentiating the function, setting it equal to 0, and what I want to see is the 0 appearing in here as well. I'll get 1 mark here for getting the x coordinates of the stationary points, another mark here for getting the y coordinates of the stationary points, a mark for setting up the nature table correctly and making a correct statement there. So that's 1, 2, 3, 4, 5 and 6. So that's 6 marks for part B. For C, what we'll go for is, we'll go for 2 marks for the drawing. What we'll do is 1 mark for getting the shape correct. I'll get 1 mark for labelling the points correctly. And then finally 1 mark for sorting that out from there and stating that x is greater than 3 upon 2. So this question here is quite a high mark question. You know, 3 for part A, 6 for part B, 3 for part C. Well, that's out of 12 marks.